Okay, so right now we just did the first one, the empty cart, and it was the mass of 30 kilograms, took 3.5 seconds for Mr. Kendrick to go that distance, and took him 14 feet to stop. So now we have this cart, I'll show you over here, and we've loaded it up with a bunch of those textbooks. We put in 25 textbooks, and each of those textbooks is about 2.2 kilograms. Okay? So, 2.2 times 25. I better do this on my watch here. So, let's see. 2.2 times 25 is 55 kilograms. Plus the 30 of the cart makes a total of 88 kilograms. So we've got almost triple the mass here. Okay, we're gonna do this again. We're gonna go out in the hall. Mr. Kendrick's gonna push that cart. He's gonna see how quickly he can push that distance. And then when I say stop, he will try and stop the cart, and we'll see if it takes him more or less time to do that. So I'm resetting my stopwatch. And again, he's going to push until I say stop, which will be right there. All right, Mr. Kendrick, are you ready? Set. Go. Stop. And right there, and let's measure the tiles. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 tiles. Okay. And the time on that was 4.01 seconds. That's actually pretty good. He did pretty good on that. Took him about a half a second more. So what did we just say? 4.01. And the distance, I forgot. Mr. Kendrick, what did we say for the distance on that one? 30? And the stopping distance was 30 feet. So, more mass. He was able to push it. It took a little bit more time. He was probably pushing with more effort. Let's ask. Mr. Kendrick, how did it feel pushing the first one versus the second one?
The second one was obviously much heavier.
Okay.
So it took me
A lot more effort.
More effort to get it going, and a lot more effort
To stop
it.
Okay. So we got that first number wrong. It was 24 feet the first time. It took him another 6 feet to stop it. And it took him another half a second, but he was pushing with a lot more force to get it going in the first place. So the whole thing with inertia is that the more mass you have, you can see that we tripled the mass there, the more force you've got to apply. Mr. Kendrick had to push harder, and it took a little longer to get it up to speed. And it may not even have gotten up to the same speed. We don't really, well, it wasn't the same speed because it took 4 seconds. And then the distance to stop, once it was moving, it resisted the change, right? It didn't want to stop. An object in motion wants to stay in motion. So he had to pull on it pretty hard, and it took him an extra 6 feet to stop. So that's what inertia is all about. Inertia is that first law, right? The empty cart was easy to get going and relatively easy to stop. Yeah, I guess we should factor in Mr. Kendrick's mass in that too, probably. And then the full cart was a lot heavier. He had to push harder. It took him a little longer to get it that distance, and it was harder to stop because an object in motion wants to stay in motion. It didn't want to stop. So we had to pull back on it harder, and it took longer. And an object at rest, the heavier it was, the more inertia it had, and it wanted to stay at rest. It was harder to get it going. Okay, so that's our little talk on inertia. The main idea here is more mass means more inertia, more of a resistance to that change. That's the idea I want you to get today. Okay, thanks guys.